Hi friends, this is N. Rakesh Reddy studying BTech first year Electronics Communication and Engineering in Johnson's Institute of Technology. Today we will discuss about applications of differential calculus in digital music. First, we will discuss introduction. Music theory analyzes the pitch, timing and structure of music. It uses mathematics to study elements of music such as tempo, chord progression, form, and meter. The attempt to structure and communicate new ways of composing and hearing music has led to musical applications of set theory, abstract algebra, and member theory. Observe the diagram. In diagram there are bright lines. That bright line shows the spectral components. A spectrogram of a violin waveform with linear frequency on the vertical axis and time on the horizontal axis. The bright lines show how the spectral components change over time. The intensity coloring is algorithm. A music is a function. Calculus plays a role in music because every music piece just is a function. If you have a loudspeaker with a membrane at position f of t at time t, then you can listen to the music. The pressure variations in the air are sound waves which reach your ear, where your eardrum oscillates with the function f of t minus capital T plus g of t, where g of t is background noise and t is a time delay for the sound reach your ear. Plotting a and playing works the same way in mathematics we can play a function. Now the waveform and hull. A periodic signal is the building block of sound. Assume g of x is a 2 pi periodic function. We can generate a sound of 440 Hz when playing the function f of x equal to g of 440 into 2 pi x. If the function does not have a smaller period, then we hear the tone with 440 Hz. A periodic function g is called a wave function. Here we have graphs. Observe that it is about the hull and null waves. The waveform makes up the timbre of a sound, which allows to model music instruments with microscopic terms like attack, vibrato, coloration, noise, echo, reverberation, and other characteristics. The upper hull function is defined as the interpolation of successive local maxima of f. The lower hull function is the interpolation of the local minima. For the function f of x, sine of 100x for example, the upper hull function is g of x is equals to 1 and the lower hull function is g of x equals to minus 1. For f of x equal to sine of x, sine of 100x, the upper hull function is approximately g of x equal to mod of sine x and the lower hull function is approximately g of x equal to minus mod of sine x. The mathematics of electronic music. One of the different aspects of the study of electronic music is the accurate description of the sounds used with traditional music. There is a general understanding of what the instructions sound like, so a simple notation of violin or steel guitar will convey enough of an orgal image for study or performance. In electronic music, the sounds are usually unfamiliar and a composition may involve some very delicate variations in those sounds. In order to discuss and study such sounds with a required accuracy, we must use the tools of mathematics. Digital audio. Digital audio is also the name for the entire technology of sound recording and reproduction using audio signals that have been encoded in digital form. Digital audio is a representation of sound recorded in or converted into digital form. In digital audio, the sound wave of the audio signal is typical encoded as numerical samples in a continuous sequence. For example, in CD audios, samples are taken 44,100 times per second, each with 16-bit sample depth. How music can help improve learning mathematics. Music can definitely be used to help improve the mathematics skills. of any students. For a start, music is actually a lot more analytical and mathematical than you might think. To effectively play music, you need to develop your critical thinking and problem solving skills. You also often need to do several things at once. You need to read music and translate that into a physical action with your hands, fingers, mouth, tongue, lungs, and even feet if you are lucky enough to be a drummer. You are doing all of this to express yourself artistically, but the process of turning that music on paper into a physical action is actually a bit of a mathematical equation in itself. You need to understand that the certain piece of musical language translate or a particular movement, and when things change you need to learn how to compensate for it. In a lot of ways that this practice is a bit similar to the principles of algebra. Music is also full of fractions. There are whole notes, half notes, and quarter notes, all of which follows the same rules that they would in a math equation. There's also rhymes and tempos involved. Most of us can remember elementary school music lessons where we learned that a walls in normally in 3 by 4 time. Mathematics is quite literally the study of a relationship between numbers, and basically if we replace those numbers with notes, rhymes and timings, we have music. Using music to build mathematical skills in early learners. We might have seen children musically engaging with mathematics without even realizing it. Often, one of the first way kids learn counting is through rhymes. They might bob along to their favorite song and clap their hands together. Technology. The above diagram is Sony digital audio tape recorder. Digital audio is used in broadcasting of audio. Standard technologies include digital audio broadcasting, digital radio, modal, HD radio in band on channel. Digital audio is recording. Applications is stored on audio specific technologies, including CD, digital audio tape, digital compact means CD, and mini disc. This graph indicates the sound wave in red and digitally in blue. Digital audio technologies are used in the recording, manipulation, mass production, and distribution of sound, including recordings of song, instrumental pieces, podcasts, sound effects, and other sounds. Modern online music distribution depends on digital recording and data compression. Okay, thank you, friends.